and some heat treating, because I know people are going to get their panties in a bunch and go goo. Is it good?
Yeah, it's all ready to weld whenever you get a chance.
Okay, did it break through again?
No, I didn't see
Okay,
it break
I'll see it. I'll be out there in a minute. So here's the deal, and this is going to upset everybody. I want to say a couple of things. I'm going to talk a little bit about heat treating in the industry a little bit. Now, guys, I've heat treated a few knives, not a couple, not several hundred, not 1,000, not 10,000, probably more like 100,000 blades. Okay, so I'm not like a complete neophyte. I know there's guys that have heat treated a lot more than me. There are a few of them, not many, and I do a lot of it by hand, and I don't do as obviously much the last few years because now the company's in a different place. But I want to talk about heat treat. I want to talk about how it is in the knife industry in general, and I want to talk a little bit about kind of the opinions and proclivities in the manufacturing environment. So Laren Thomas, who is one of the developers behind it, I believe he's the son of a knife maker. And I hear lots of stuff from everybody, so I try to stay a little bit vague so I don't get details wrong. I've spoken to him on the phone. He seems like a really nice guy. He seems really knowledgeable. I actually, a couple days ago, watched his 31-minute video on the science of Magnacut. I want to preface everything I'm about to say about Magnacut and the steel in our process with this observation. Good science happens with great observation. It starts with great observation. It's an old axiom of methodology, and we observe and do a lot. We don't send out a little batch and come up with some ideas and theorize what we do. We've been making blades a long time now. Well, like 12, 13 years. We've been making blades and made a lot of them, and we do them all in-house and we do them all by hand. The only time we ever outsource a batch of heat treating is when I have so much of one thing that a friend of mine who owns one of the top aerospace heat treat companies in America, when I've got enough to do a whole oven and I know it's going to unburden a backlog, it's just kind of a stopgap measure. But I know I've got a whole oven and I can kind of control the whole thing. And I don't do that often. I've only done it 2 or 3 times in 13 years. I have sent batches out to lots of people to have them heat treated. And you get these nice certs back, these papers that make you feel good because they're aerospace certs. And when I go through and test them, the certs never are accurate. I don't mean sometimes not accurate, I mean never. I never send out a batch of knives and get them all back within spec, ever, no matter who I send them to. Now, there are a lot of reasons for that. Heat treating and hardening of your blades is one of the things that can kind of make or break the reputation of a company. So I've wanted to kind of keep control of that. It is the kind of thing you want someone experienced doing. It's not a laborer job, it's a craftsman job. So when you send it out to a big heat treat shop, who knows who they hired this month, this week? They're very process driven. They're not as craftsmanship driven. Now they'll say they're craftsmanship driven, but they're not. They're process driven. And these big commercial ovens, they're not made for doing these small batches of knives. Now, if you do big batches of knives, they're more made for that. And sometimes you can get away with that. But I just haven't found the consistency there that I trust. The other thing that happens is vacuum furnaces don't quench as quickly. Now think about it. If a vacuum furnace weighs, let's say it weighs several thousand pounds, all of that mass is holding heat, so it has thermal inertia. It likes to kind of stay where it's at, and when you change its temperature, it changes slower because there's all this mass there holding the heat in. Think about it. You have a 10,000 pound block of metal, you heat it up to 1,000 degrees, you come back 3 days later, it's still hot to the touch. Have a 10-pound piece of metal, heat it up to 1,000 degrees, and in 30 minutes you can lay your hand on it, no problem. So we all know this intuitively. But you have these big mass ovens, and what they do is they rely on lots of, it's a big cast iron or cast steel autoclave with an oven inside with a bunch of insulation, and then they try to quench And the quench is not as dramatic, it's not as good, it's not as fast, because let's say it's a 2-bar nitrogen quench. That means you've got 2 atmospheres of nitrogen. It doesn't have the thermal draw capability because it doesn't have the mass. It doesn't have the mass to absorb the heat. So I have found vacuum furnaces don't get as hard a hardening process as plate quenching in an atmosphere oven. So the reason to go to a vacuum oven is labor. It cuts down on labor and it cuts down on craftsmanship. I'm not saying it doesn't take skill to run that. I'm not saying it's not a complex process, but it doesn't require somebody making Inconel bags and ripping them open while it's red hot and hand quenching and hand straightening. It leaves all of that to the process. They say, oh, we hang it vertically, they don't warp. Yes, they do. They still warp. They all warp. Guaranteed, always. So that's a little primer on why I heat treat in-house. And I've talked about heat treat ad nauseum for years. I just haven't done it recently. Now let's talk about Magnacut for a minute, because this is I wanted to frame the conversation and talk about Magnacut. When I started using Magnacut, it was pretty new to the business. It does not have a big track record. It's a newbie. Now, the scientific data on it suggests it could be potentially awesome. It has some characteristics about it that run very counterintuitive. It is very counterintuitive that as you approach 62 and 63 Rockwell on the C scale, that its toughness goes up. That's very counterintuitive. That's not normal. Normally, the more hard you make a knife, the more brittle it becomes. So it appears to have some magic about it. Now, that has yet to be really sorted out, in my opinion, because only time will tell. I have seen in years and years and years of metallurgy and making and knives that you don't get anything for free. So if Laren has come up with some genius material that does some genius things that are outside of the normal material science experience, I need to see that proved out over time. And I'm not doubting him. He's way more into metallurgy than I am. He's way more schooled and versed on this clearly than I am. You know, us knife guys want to make knives. We didn't get into it because of metallurgy. We get into metallurgy because we need it for making knives. Metallurgy is a secondary skill. It's not a primary skill. Laren, I think it's his primary skill, which means he's going to be a master at it. And I would not, I wouldn't go toe to toe with him countering what he says on it. Experientially, what I have found with all of the different metals I have used from Crucible, S30, S35, S45, S90, S110, S7, D2, CPM D2, CPM 3V, and various other metals we've tried. They all behave in a very predictable fashion, which I really like, and I've been able to use the spec sheet, the data sheet. It's been very useful to get me to a recipe that I like. Now, it is never me second guessing the PhDs who came up with the recipe. We all have an environment that we work in, and we have certain needs that are better for us. And you can't just have a different process for everything you do. Sometimes a steel comes along and I go, yeah, I don't want to try and bring that process in. I don't want to do salt, molten salt heat treat. I don't want to do that. It's a whole new thing I don't need to have in my building. There's a lot of things about manufacturing that kind of hamper you and hobble you. One of those things is when something new comes along, you have a tendency to want to really err on the side of caution and sneak up to ultimate. You don't come out of the gate with ultimate. I find at ultimate is where you're going to have the most amount of chance of a tire blowing up and hitting the rails. So I don't come out of the gate on new products, new steel, new anything, trying to do ultimate instantly. I kind of sneak up on it. Now, Magnacut. I use the data sheets on all of these other metals, as I mentioned, that come right from Crucible. It's a printed data sheet. Let's see if I've got one. I might have one sitting around here. I have one sitting here. Give me 1 second. I'm going to reach over and grab this one right here. This happens to be Crucible's data sheet for Magnacut. So as you can see here, it's a bunch of data and graphs and information and suggested processes. Now, I really trust these. People have said to me for years, Greg, how do you come up with all this stuff? All these metal, where'd you get all this? How do you know all this stuff? And I always go, I read the data sheet. I just do what the data sheet says. The problem with Magnacut, in my opinion, and so it may turn out to be the greatest thing since sliced bread, but for me, so far, as wonderful it is, it's a big kind of pain in my ass because it doesn't do exactly what the data sheet says. Now, I use new Paragon ovens. They've got 3 temperature sensors in them. I know exactly where my temperatures are at all the time. We know within a couple degrees, and we know zones in the oven. I know what temperatures that I'm heat treating stuff at, what temperatures I'm holding them at, and I know exactly how I'm quenching them. And then we hardness test between every single step. Now, I'm not going to do a deep dive on carbides and carbon melting into the structure as it approaches critical temperature, passes through it. I don't want to talk about, after when you overheat steel, what happens and how it degrades other properties of the finished product. I would really leave that to experts who that's their field, and maybe it's what they went to college for, maybe did their dissertation on, maybe they've specialized that for the last 20 years working in a steel company like Laren. I would never question his knowledge. What I want to talk about is my experience and my approach and why I'm where I'm at with Magnacut. So we decided not to launch it as a steel company wide. We were going to do special projects with it because it requires a little special attention. As we heat treat it, what we found when we used the recommended 2050 Fahrenheit austenitizing temperature, when we use that temperature, it doesn't get us what it says it's supposed to. Now, if I look here on the graph, just give me a second, and I'll tell you what I mean. I may not have the whole thing here. Okay, austenitizing plate oil quench room temperature, minimum austenitizing time. So 20 minutes at 2050. And I do a temper at 350. I get 61 and a half. Freeze -10 after plate quench. 61 and a half. Liquid nitrogen, 62. All right, so I want to tell you what we've experienced. I hear a lot of guys talking about getting 63 and 64 hardness out of Magnacut. We've never seen it. We've tried to over temp it at the suggested temp and below, and we've never, ever seen it. It seems like at 2150 for 10 minutes, some guys say they can get it. We just haven't been able to repeat that, and it hasn't been consistent. The other thing that we get is we get thermal distortion. We get warping that happens. So we found at 2050, we get more warpage than we like. We found at 2000 degrees, we get warpage that is tolerable. And we found at 1950, we get no warpage and it acts like our other steels. Now, what that means is we get just like the spec sheet says here, we get a Rockwell hardness of around 59. Now, we always say plus or minus 1. That's what the folks on the phone say if you call up and ask. And I'm a little bit of a, all these steels get up to the top of their curve and start competing right up here. And there's all this performance along the way. And guys really argue about all this up here. I don't get too worked up about all of that. I'm not doing a competition. I want to make something really reliable that meets the greatest amount of my customers' needs and causes me the least amount of problems. Now, we've done stuff. I can get CPM D2. I can get that to like 66 on the Rockwell C scale. It's kind of brittle. I've sent them out at 64 and 62 on request to a customer back in the early days. You know what I found? They couldn't sharpen them. Now, that was 13 years ago. So there's been a lot of advances in sharpening technology also, and I got to keep up with the times. So out of 100 knife buyers, a certain amount of them have diamond sharpening systems. It's a small number. What that means, though, is the big number has a hard time sharpening their knife because it's too fucking hard. Now, if I'm going to go for this steel and I'm really going to swing for the fences and I want to make the absolute, not optimum, the maximum performing blade, then I'm going to do a shorter time in the oven at a higher temperature. I'm going to do the quench at 350 and I'm going to be shooting for the 62, 63 Rockwell hardness, maybe 62. I just find if I do that, it starts jamming up a larger number of my customers. And at the end of the day, I'm trying to figure out how to best serve the market. I know how to run a little hotter oven. I know how to quench. I know how to do this. We decided that we would go with about 60 on the C scale, plus or minus 1. Now we say plus or minus 1 just as a kind of parenthetical expectation of heat treating business. Now, you get a little dust particle on, you can get a minus 1. You test it on a harder spot or right on a carbide maybe, you can get a little bit harder. It can test a half a point harder. Every time you test the blade, you put a little diamond impression mark into it. So you only have a kind of limited number of places to test and times you want to test. We could test 5 times on every blade and average it out and we'd come up with a really good number. So the truth is, we're at between 59.5 and 60.5. You get very, very minimal diminished maximum performance. I'll say this again. Our final product gets you a knife at 59.5 to 60.5. Okay? If we do a 1950 heat treat, plate quench, cryo, it'll pre-draw test at 61 HRC. And after we do our draw at 350 2 times for 2 hours, we get 59.5. Do you know what we get? We get a really good blade. Now, if people are doing experiments that are saying that it's tougher at the harder hardness values, and that's coming out, it sounds like there's another knife company using a lot of this. It sounds like if they're having that experience, which I've just heard about, we'll start testing it a little bit. I just watched that video, and Laren says in the video that is the case. Very counterintuitive. I'm happy to dive into that. But I don't take everybody's word at face value. I have a tendency to trust and verify. I trust the science. I trust Laren. I think he's an amazing asset to the knife community. I think he's an amazing asset to the knife community, an amazing asset to Crucible and to Niagara. Anytime you get somebody who happens to be from the knife community, who happens to specialize in one of the behind the scenes supporting materials, I think it's awesome. It's good for all of us. The reason there are so many videos and so much discussion about this is because I've talked to a lot of knife makers who are trying to use this stuff, and their experience is confounding. So, what happens? I'm kind of a big mouth, and I kind of say what's on my mind. I shoot these videos, and you know what? Knife people kind of watch the videos, even the fuckers who hate me. Now, they show up at Blade Show off to the side. Hey, Greg, nice to see you, man. That shirt you did was nuts. Hey, have you been using any Magnacut? What are you experiencing? I probably got 30 guys walked up to me at Blade Show and asked me, unprompted, hey, how's your experience been with Magnacut? I've never had that before. Now, why is that? Because everything's going perfect and they just want to talk about it? Or they saw that I was doing a project with it, I launched it, I told people about it, and then they're having some challenges with it. I think it's B. Now, I didn't do a scientific questionnaire to find out what everybody was worked up about. But I had a lot of people talking to me about Magnacut. And I know guys in the community that you all know who have said to me flat out, yeah, I played with it. I don't want to use it. Now, I'm not saying there's anything wrong with it. Maybe they don't have the right equipment. Maybe they've got a way of going that kind of fits their spirit and their thinking, and it doesn't fit their groove. I get it. But the reason there's all this discussion is because it's not because knife makers are a bunch of dummies. It's because we're having an experience that's outside of our historical experience based on these data sheets, which we use to do what we do. Now, I listened to Laren's video, and my takeaway from that was, the biggest thing I learned was that my reticence to go for the hardest possible finished product, because I want in all of the steels I have experienced here on planet Earth in my 52 years, the harder they get, the more fragile they are. I've wanted to err on the side of caution as this steel kind of gets its legs out in the industry. And when there's more and more experience about it, I'm sneaking up on those harder end results. So we can really easily be launching 61, 62 Rockwell knives to you guys. But that's so far outside of my historical trend making tough knives that it just spooks me a little bit. Now, let's say you have flown in an airplane and you have experienced some mock tuck. Mock tuck is when you get an airplane in a dive going so fast that it wants to tipple forward and rip the wings off, and you can't recover from it. Let's say you've experienced that, maybe in a P-51 diving. And somebody says, hey, we got this new airplane. Why don't you take it out and dive it? And you've experienced mock tuck before. And you go, yeah, this new airplane doesn't have swept wings. We know that fixes mock tuck. I don't know. It makes you a little cautious. So what you do is you do test flights. Airplane's working, you dive it, you work your way. I'm working my way to it. Now here's what I won't do. I won't just toss over the reputation of my company to somebody else, or a scientist, or another knife maker, or another heat treat company. I just won't do it. So everybody's, I've had, now we say a dearth, I've had 6 queries about this from thousands and thousands and thousands. I've had 6 queries in the last month about Magnacut. People are watching the video and they're asking, and I'm glad they're asking. And it's wonderful people watch these videos and kind of nerd out on carbide and vanadium and the austenitizing and martensitic crystalline structure and all of that. It's really cool that everyone's talking about it. And as you guys are talking about it, I've got, my company, my reputation. Look, my reputation's a prickly son of a bitch, but I make good knives. If someone says he's a prickly son of a bitch and his knives are shit and they break and they're not sharp, well, then I get, what happened? So then them's his fighting words. So I don't want to give, people say that stuff about every company. Every company has got some group out there to talk shit about them. So I know that's going to exist. I don't want to give them unnecessary fodder. So I'm working my web. So right now we started initially at 1950 and a final hardness of around 59.5, very consistently. We snuck up to 2000, very consistent Rockwell hardness of 60.5. At 2050, which is as far as I want to go, we seem to be getting a real consistent 61 HRC. And that's probably where we're going to stay, because I don't want to go to that next level. I don't need to go to that. Just like, look, you don't need to go to that next level. I don't want to burn my ovens out, cranking them at the higher temperature. There's no benefit to me going up into those crazy hardness values. There is a balance between practicality, makeability, repeatability, and fad. And we have to balance those out all the time. Now, I think Laren may have come up with a new steel that's got some amazing new properties. It's got some amazing new counterintuitive characteristics. That being the case, a lot of times we're all talking about the very top of the graph, and there's a lot of graph down here. So I don't know in the grand scheme of things how much it matters. It's a lot of sizzle. Now, the guys in the steel business, whom I love and I consider dear friends, and the guys in the making steel business, I admire, respect, and appreciate them so much. But they're nerds selling nuance a lot of times. The truth is, these blades will all work with 1095. The truth is, these blades will all work with D2. The truth is, S35 is fucking fantastic. The truth is, S45 is a little bit better. The truth is, Crewware is awesome. You can make great knives with all this stuff. So a lot of times, it's just arguing about who you like fucking. I like a blonde. I like a brunette. I like a redhead. I like it this. I like it that. Then you get on the redhead forum. You talk about that for 4 hours and say how blondes are ugly. So, for everybody who's all worked up about Magnacut, calm down. For everybody who's all worked about it being at 59.5 or 60 instead of 62, calm down. You'll need an expensive machine, years of experience, and thousands of hours to even be able to differentiate it if it's not marked. Calm down. Magnacut's not going to be my core steel. I'm not totally in love with it yet. I'm taking my time. Sneaking up on it. Everybody was mad at me that I used D2 back in the day. I used D2 back in the day because you could heat treat it with a fucking blowtorch, you can heat treat it with anything. It heat treats. Old timers, if you ask them, they'll say, I'm less concerned about steel than I am how good the heat treat was, how well it was done. The heat treat's the most important thing. Here's what I know about heat treat at my shop. We do it all. We don't outsource it. We make every Inconel bag. We test every single one. We don't go off what someone tells us. We don't go off a spec sheet or a data sheet telling us what it should be. We test and see what it is. We do it on every blade, every time, at every step. I would venture to say there's almost nobody who tests blades and their hardness and outcomes more than I do. Because I test everything, 100% QC at each step. That's 3 steps a knife, every single knife. I wear out hardness testers. Now, hardness test isn't the only thing. But when your recipe is right and the data sheet is accurate, hardness testing post-heat treat tells you if you shot the cannon in the right direction. That's exactly what it does. And then you verify it after the draw, you verify it after the quench, you verify it after the cryo. I think I have some Baker Forged Damascus. All right, you guys, that's my video on Magnacut. It's a wonderful metal. We're making really cool knives with it. It's kind of quirky. It didn't act like I expected it to. It's got a couple of counterintuitive properties. It makes me run things a little differently. There's a lot of ado about not much, and everyone needs to fucking calm down. It's just a cool new brand right now. And in a few years, something else will come along. And at some point, 90% of the marketplace will say, I don't own a diamond sharpener or carry one around me when I'm out in the field, so I don't really like my knives that hard. You know, my knives, I make a lot of knives that end up out in the field. And out in the field, most guys are not carrying fixed angle diamond sharpening systems. They want to be able to sharpen it and do improvisational sharpening. They can't do it at 63 and 64. They can barely do it at 61. At 59, they can do it. So I have more things pushing on me than a couple of nerds who want me to drive it up into the coffin corner of the absolute maximum. I'm not pushing for maximum. I'm kind of going for optimum. And optimism is the thing that causes me and thousands of people I take care of the least amount of pain. All right, that's Magnacut. I'm out.